Hello and welcome back to another video of Advent of Code. So this was something I started last month in 2022, we're now 2023, but yeah, I believe the last video we were looking at day 16, and since then I've had a bit of a break and did some stuff off camera. And in doing that, I have improved the speed of day 16 quite considerably. So it took like 3 hours or something to get part 1. That was just too slow. And in working on the part 2, I basically did a bunch of optimization, which unfortunately, so if we have a look at it, no colour here, that's right. Yeah, so in this, basically I've done a bunch of stuff so we can basically use different data structures. So I've defined like a priority queue, which uses my own like set definition, because the sets in Serenity, like you can't override the sets in jakt, you can't override the hash function, so I just made my own set thing and priority queue with it, and with all of that it reduced the runtime down to like 10 minutes for part 1, I think. So I've been trying to get this going. I'll kind of just show you what happens when we try and run it. We get a bunch of stuff. Well, actually no, that's different reasons. Maybe if we go into source and move jakt to jakt new and move jakt old to jakt, and maybe if we try and run that again, yeah, cool. And in here we need to get ref log, and we want to just be on 29b. Let's check out 29b is enough here. No, it's not. F5DC. F5DC. Was it DC or BC? It was that, cool. Maybe we can be in here and get old code. So some jakt to show where I was at. Right, so that crashes in the compiler with this generic trait instance in CodeGen, which potentially we might be able to fix. So what I was thinking was I can see on my host machine we can compile that and it will just run fine. There have been some improvements to the compiler, so I was trying to rebuild it, but there is some stuff with yeah, I added some stuff. So that was complaining about generic trait instance. Yeah, so I wonder if we can do this, because that's that line there. Yeah, so we might actually be able to get it onto Serenity. The gist was that when I basically did a pull, I thought it knew this. Gosh, I don't have all my AS check out main. So this was where we were, and our problem here is when we try and build it, it runs for a bit, but then it fails in the C++, in the actual building the compiler. But what I'm thinking is, well, I'll let that run just for a second. What I'm thinking is I might put in, change this here, and you'll see in my code I just return auto there. I was trying to work out how to do it the proper way, I guess, but then it just, it didn't quite work there. And there was also this error that came up that I did. And I filed a couple of bugs on the old GitHub. Yeah, GitHub is where the issue tracker is hosted. So basically, in designing this, we look at priority queue. Basically, in building this, I ran into a bunch of compiler issues to do with like types and generics and kind of mixing traits and stuff. Because I kind of wanted to make it nice and reusable, which ran into some issues. So that is that. Now this is like taking longer. I suppose I'm like recording a video now, so I'll call it that. But this should theoretically fail, and when it does, I'll probably backtrack to the build that can build itself. Actually, I've realised why this is failing. What we need to do is maybe, like, it's running in the background. I think I need to just kill that CMake process. Just do it, mate. And also Ninja, because I guess, so we need to kill almost 9 Ninja. Cool. So that gets our Ninja back. And we want to set the source there. So it was like trying to clone in the background. This way it'll hopefully be a bit more responsive. So here that's better. I will take it. Build build.ninja and 835. Gosh, will this compile? So this was like just a known issue. 2420, that one. And then it'll be those two lines, and now if we run it again, it'll do that, but then it might fail at this stage again. I suppose I hadn't got up to the stage on this. I think it was after doing stage 2 compile. So it compiled stage 0, compiled stage 1, then when it was trying to rebuild the self-host, it then failed. But hopefully we'll see that. If we that key, that key. What I did is on day 12, I also kind of tested this. So this has a similar kind of copy paste. For some reason I couldn't keep it in a separate file. Like I had a separate file here. I couldn't just go like in day 12 import priority queue or priority queue, and like something like hashable priority queue, which is the thing. When I did that, I can't remember what error I got, but like it failed in the actual compiler, so that's having some issues there. I found it easy just to copy paste it. So how this priority queue kind of works is we'll look at day 16, because that is what we had been working on. Maybe we'll go full screen there. So basically everything that we want to have in a priority queue, we need to have some comparison function to see whether it is better or worse. So basically whether it should be at the front of the queue or at the back of the queue. And we also kind of need a few things, because in A* we do contains call, and to look up whether something is contained in a priority queue, the best way to do this is probably have a set of nodes in the priority queue, rather than how I was doing it before, was just going through all of the data in the queue and then seeing whether it's the thing that we're looking for. But if we just have a hash set type thing, then that works a lot better. So to do that, we need to have a hash code type thing. The comparable was to work it out, and equatable is something I just chucked in to see whether, if you have hash, whether something is actually identical, because the hash might be the same for other things. You get collisions and stuff. So in here, I can't recall exactly where it was up to, but yeah, basically we parse the input and we build up a graph of valves, and we kind of skip all the intermediate steps, and we only care about the ones that go to valves that have non-zero rate, and we do that using Dijkstra's thing here. Basically run over everything, and you'll see that we use that hashable priority queue there. So that's why Valve has that hash thing. And so these functions, they're pretty simple. So for a valve, the hash is just the hash of the valve name, so like AA or BB. Equals is just seeing whether that name is the same. And the compare is like a bit different. So here we wanted to base it off the tunnel weights from like where we're coming from, I guess. So we have like, because Dijkstra's goes from a source node to all the other nodes and works out the minimum distance. So from here in the compare function, we want to get what the source node thinks our distance to here is, and then same for the other one, and then return the best one. So that's that. And then for node, that's our other kind of class structure type thing. I did a few things to kind of free up space, I guess. So our valves is actually now a class, so it's done by reference, and we just have it stored there, because before we were having this dictionary, and that was in every single node, which was just a bit too much memory when it just kept on going and going and going. And so here we have a bunch of stuff for part 2. So if elephant is basically if it's part 2, and here, like, I feel like it's getting all the right neighbours. It works for the example case. One thing I found when running it on the actual input was this line was being caught because minutes remaining was wrapping around and becoming negative, which is not kind of what we want. And yeah, I just kind of ignore this area, so I just like, cool, who cares, I'll return from that. So that is all that code. It's quite verbose, but hey, that's what it is. The general gist is, when we're at one node, we're either in a state that we, not the elephant, are halfway to a node that we're going to open, in which case we want to pick a new node for the elephant to go to, and then whoever gets to that next node first will be like the next state. Otherwise it could be the other way around, the elephant's trying to get somewhere and we just pick a new node, or we're both on a node, so we both kind of arrive to a node at the same time, turn it on, and there we just want to pick 2 nodes and go to that and kind of measure how many minutes remaining to our next goal. And that kind of works. It works for the example input pretty close. And here we have our like heuristic function. So here I tried like a couple. So I kind of, some work, some don't, and I was just trying out some, and some of it was based on what a friend had done, but it doesn't seem to work for my actual input. It returns a too low a number, so the heuristic isn't good enough that the goal comes first, which the goal is the best. And then the equals is pretty straightforward. Basically, we test all the where we currently are, how long it's taken to be there, what our current open things are, and then that just checks the size, and then we check whether the valves are kind of the same. And the compare just uses our f function and returns the biggest. And hash kind of just takes similar information and makes a string and then hashes it. And so A star is fairly similar. I added in some like debug code type thing. I heard some things stop spinning, so I might just temporarily go back here. Yeah, so this is failing in compilation on like the new stuff. So what I think I want to do is I want to like reset to this old one that I know kind of work. That one, oh no, that one without the G. Maybe I want a much hard there. Yeah, so what? Yeah, I think I'm gonna do something like that, and we'll fix it up, and also samples runtime. So we kind of just want to do like everything. Bootstrap samples run. Like do this again maybe, and maybe just remove this and main. I can't remember what was going on there, and get hub scale and maybe do that reset again. So here we're kind of where we were. So if we run Ninja, that should yeah, cool, that's fine. Target 4, yeah, that's it. 4, and 2, 4, yeah. Do that, and if we run that again, that should probably do it in the background. So in my A star, it's fairly similar. It had some debugging stuff, and for part 2, I was like, it was giving me the wrong answer, so I just kind of was saying, hey, if you got to the wrong answer, then skip it, I guess. The problem with that now is it goes too long and doesn't actually get me the answer. But if we, what do we do? Time tests. So if we run this, we can kind of see how the actual input and so the example passes quite quickly, less than a second, and the actual I think takes like a couple of minutes. It might take a bit more because we're like streaming. So this also, oh no, this is just like warnings. I'm happy with warnings. It's got a few warnings. Yeah, it's literally pumping out a warning for everything, but that's right. As long as it kind of compiles. Otherwise, I think we're at a point because no, I don't want to do that, and I am unsure how I. I did that. Control Shift F, but I want that one. Control window. Actually, it'll probably tell me Control Alt F will get me there. So if we go into, are we doing it? No, we're not. We're too busy compiling. I was thinking we can kind of run yeah, so we've still got that bug. So once this compiles, if it compiles, we can fix that and kind of have things running, I guess. But yeah, back to this. So yeah, it took a minute and a half, and that was just for part 1. So we just exit early on part 2. If I ran it for part 2, it currently takes an hour, and then it just crashes, runs out of memory, like it uses 15 gigs of memory or something. So the heuristic is just not right there, but this minute versus 3 hours is a lot better. So this kind of shows that the approach of optimizing it with the hash set, the priority queue, works, and it does it quite well. And I also did like some other things, tidied up the zero flow nodes, like actually removed them because I was kind of parsing along for everything. But yeah, that's basically that. Might have a quick look at how I do all these things. So jakt has like the notion of traits, and here we've got a trait with a generic. So basically we can have a trait, and then in like defining a generic, like on a class, we can say that it requires some sort of traits. So here's like a list. I believe it's basically a linked list type thing. It's quick and easy to do, and this has an iterator. Some of these data structures I've made iterators for. Some did not work that well. But yeah, so that's pretty straightforward, just a linked list type thing. Then set is one that doesn't implement the iterator, and all the iterator does is kind of just does that, or it has to define the next thing that returns an optional, so none if nothing. So here in set, it's kind of like we just have a big dictionary from hashes to values. Well, hashes to like lists of values, so like it's like a bucket, and that bucket is just a linked list because hey, it works. The gist is that the bucket size is likely to be small because we do hashing, but it potentially could be quite large. And like at some point I had that there to kind of like force collisions, so like the hash was always within 10, but then that like caused some more issues. So that's like just a pretty basic hash set type thing. Then the hashable priority queue is basically the same as the priority queue, which I would find a bit below, and you'll see here it's got the priority queue and everything kind of just adds to it. But it also, like, yeah, it basically calls it out to that. I wanted that to be like this class extends from a priority queue, but there were some errors. I can't recall what they were. But also because it's hashable priority queue, we can have this scene set, and that will let us do an efficient contains. So this should be like order 1 type thing, and all the other operations should be like order log in, so a lot quicker. The priority queue, this does like all the work. So when we push, we basically push to the back of it's using a min heap, or a heap, I guess. Min max doesn't really matter, depending on how the compare function goes is basically how that defines it. Basically when we add a new thing, we add it to the end of an array, and then we kind of shift it up. And the general gist with a heap is, I wonder if this has anything here. Nah, not on the screen, but basically for every index, that is a root of some heap below it, and its index times 2 is its left child, and its index times 2 plus 1 is its right child, and the root will always be bigger than its children, but it doesn't really say whether the left is less than the right or anything like that. All it knows is the root is less than its children, and going down, that rule should apply the whole way. So that's kind of what we do in this sift up type thing, and the remove does a similar thing, except it kind of goes down the other way. When we're removing like a particular value that's not like the front, so to remove something we basically swap it with the last one, the thing that we're going to remove, which is normally the first element, which is the best, the one we should pick. We will swap it with the last one, and then we'll shuffle that down. When we're removing like a just arbitrary value, like this function here allows us, we'll actually have to find where it is, and here we do an efficient search. Like we could have like a set of thing to index and then do some stuff like that, but remove isn't actually used that much or at all anymore, I can't recall. But when we do that, because we're in the middle, we kind of need to swap it with the end and shift that down, but then we also want to go up as well, because we've unbalanced the array, the heap I should say, and the rest is pretty good. And yeah, so this is like the less efficient contains, is we just go through everything, and if it's the same then it's the same, but that's very taxing. Like some of the sizes of these queues were getting up in the millions. Right, this is going, and it didn't like it. Right, it's not ideal that I'm potentially in a state where I can't compile things. Well, let's try and do just day 1.jakt. Alright, I can kind of compile things, that's alright, but I can't do some. Erino doesn't like that. Now, I think this, yeah, so I've got like nothing in my diff, but there is some stuff that would be useful in the diff. I've lost it. So this one here, I believe, is because, and it's kind of been fixed upstream. I wonder if I did a stash before, I think, yeah. Show -p. Yeah, this will do it, because, yeah, basically so the host triple was wrong, so it thinks it's not running on Serenity at the moment, and this is what I had to change. So maybe if I just get stash pop that and run that again, but then also do that and that, and like run that all again, and maybe that will compile. Yeah, so that's basically that, and what I'm doing inside of Serenity at the moment probably doesn't need, I kind of just wanted to show it running inside of there, which would be kind of cool, because I kind of want everything compilable under Serenity, is this project. And to do that, we need to fix a couple of compiler bugs, like this one, where it's currently panicking. In fact, we could potentially, come on, let's do that. Alright, it's just doing that. What we could do is source jakt, get grep, generic trait, I think it was in my code gen. Yep, self-host code gen. Self-host code gen. Generic traits. Gosh, it's running slow while compiling. I'm just trying to open them. Yep, so here what we could do is probably just yield auto instead of panicking. And what was the other change that might be useful? The other one was in types generic parameter has been bound to itself. Then come on, then self-host types bound. We'll do a search for that. And here I think we just wanted to ignore that abort. Oh no, we didn't want to ignore it. We wanted to just do an early return. Yeah, we early return. Right, so what's that saves and does this? I'm like a bit anxious. There might be a kernel panic because I'm like testing this, doing some compiling while also like saving some files. I mean, it's still ticking along, but yeah. Gosh, just yeah. Actually, the mouse is locked up. So yeah, I think I don't know. There's not much point watching things compile. So there was just like an update on day 16. So basically, it's speed up quite a lot, but the heuristic is not right for part 2. So I might come back to that at another time, but I think for now I'm gonna call day 16 done in my head, and move on to other days, and try and just finish all the days, and then if we get to the end, then I can revisit day 16 and work out what's up. Because yeah, I kind of yeah. But for now, thanks for watching, and I'll see you next time for another